Okay, so can you see it's going to cut my y-axis? You know what a y and x-axis is, eh? Okay, this is your x-axis, that's your y-axis. So y-intercept is where your graph is going to cut your y-axis. Okay, so if this graph is cutting the y-axis at 1, what is the coordinate at that point? You know what a coordinate is, eh? Okay, a coordinate is made up of a x and a y value. Okay. So if I'm looking at what my coordinate is of this one, what is my x coordinate at that point? 0. It's 0. Okay, and what is my y coordinate? Okay, so what do we know with any and every x intercept? Okay? Sorry, a y-intercept, but first, before I continue, Mikhail's going to get... Okay, so what do we know about every y-intercept? Okay, the x value is equals to 0. Okay, so while we're on this point, do you agree that we can label our y-axis as the x equals 0 line? Are you with me? Okay, so this line over here, at every point on the y-axis, x is going to equal 0.
When it's on the line.
When it's on this line. When it's on your y-axis, every x value is equal to 0. Does that make sense? Okay? And if we're on the x-axis,
Y equals 0.
that's it. So we can label this line as the y equals to 0 line. Okay, do you understand? Okay, fantastic. Fantastic. Okay, so what I also need you guys to get used to is the notation in graphs. You know, normally you guys are used to having y equals 4x plus 5. Y equals 3x minus 2. We're going to start using g of x, h of x, f of x. Okay, so do you see the little note over here? If I use g of x, it actually means y. It means the same thing. Okay, if I say g of x, okay, so let's just say I give you a graph. Look here. Do you see? Look here. The first one, sketch. F of x is equals to. That f of x is the same as saying y equals.
So it's the value of y.
Okay, so yeah, so it's the same thing. This f of x and this y. If I say that, or if I say that, it means the same thing. Both of them represent y. Y equals. Okay, are you happy? I can go into depth to explain. Okay, if you've got time, I'll get there. It all just depends. If they give you a graph and they label it g of x, you can't just go say y, you need to label it. Okay. Right, so first example, we're going to go ahead. So for each graph, we're going to sketch and we're going to find the equation of. Okay, so first example, f of x equals 1 over 3x plus 2. So what I would suggest is, first have a look at your equation. So now you're going to have to know, at the end of this we're going to know a couple of functions. Okay, and you're going to have to be able to identify which type of function you're drawing. Okay, so what graph do we have here? It's going to be a linear graph. It's a straight line. Okay? Right, let's suss out what our equation tells us about our graph. Okay, there's two vitally important things that they tell you about a linear function. The first thing is the gradient, and the second thing is our y-intercept. Okay, so first things first. Can you see that our gradient is 1 over 3? So our gradient is positive. So our gradient is greater than 0. Which means we're going to have a increasing graph. Okay, are you with me? Okay, that's the first thing. The second thing is our y-intercept. Okay, and our y-intercept is that plus 2. Okay, that means our graph is going to cut the y-axis at 2. Okay, so this is our y-intercept. If I had to write my y-intercept as a coordinate, how would I write that? 0 is to 2. Because remember, with the y-intercept, x is always 0. What's going to happen is, we're going to give you the question. The question's going to say, sketch the following function. And I'm going to give you that. And you're going to have to draw that. Okay, does that make sense? I'm going to show you now. We're going to get there. We're going to get there. You guys want... Right, so... I'm going to teach you a method. There's many methods. You could use rise over run. You could use table method. Okay, table method. Or I feel the easiest one to use is your dual intercept. Okay, so you see it says here, you can use any method you'd like. However, the easiest method is your x and your y-intercept, also known as dual intercept. Dual meaning 2. And you can only have 2 intercepts on a graph, either x-intercept or a y-intercept. What do we know about an x-intercept? An x-intercept is any point on the graph where y is equals to 0. Remember, x-intercept is that point that lies on your x-axis. Okay, so an x-intercept is any place on your graph where y is equals to 0. Okay, so if we want to go and calculate the x-intercept, we're going to go and substitute 0 into wherever y is in your equation. Okay, because the whole point of us, okay, so let's quickly look here. In x-intercept we know y is equals to 0. So we know the second piece of our coordinates is going to be 0. We just don't know what the x part is. Does that make sense? So, by us substituting this 0 into our equation, we're going to go find its friend, the coordinates friend for 0. Does that make sense? Okay. So what x-intercept do we want to find for which function? Y is equals to 1 over 3x plus 2. Wherever we have y, we're going to go substitute in 0. Are you with me? Okay. And we are now back to a normal linear equation. So we're going to go and solve for x. Okay. We are going to take this positive 2 over to the left-hand side. And it's going to become a 0 minus 2, which is negative 2. Happy? Right? We're then going to multiply, because we're dividing by 3. We're going to multiply both sides by 3. We're going to multiply by 2. Please tell me, how is that going to help you solve for x? Understand? Okay? But remember what you do on the one side, you're going to do on the other side. So we have to multiply. Do you see? We multiply the left-hand side with 3 as well. Do you see the 3's on the right-hand side cancel out? Okay? We then have x is equals to negative 6. Okay, so when you're done, just getting used to proper notation in graphs, go and write your coordinate down. Okay, so this coordinate is going to be negative 6 because x's value comes first, negative 6 and 0. We substituted in 0, okay? 0's friend is negative 6. Sketching. Oh, another thing, I want you guys to add a little note here to sketch. Whenever we're sketching grade 10s, we need at least 2 sets of coordinates. Okay, we need 2 coordinates. Okay, so to sketch we need 2 coordinates. Okay, if you didn't have 2 coordinates, how would you join the 2 dots? You're going to have one dot chilling in the middle of absolutely nowhere, and then what are you just going to like close your one eye and think, okay, let me put my second dot here and let's connect them. Okay, that's why we do dual intercept. We find our x-intercept, and now we're going to go and find our y-intercept. And we know our y-intercept is where? Is where?
Is 0.
X is equals to 0. Can you see? Yeah. No. Now you see. Listen to that question. Very important question. Do we need to calculate it if it's given to us in the equation? No. So what you could do is you could automatically go and say, okay, from your equation we can see that my y-intercept is 2. So you wouldn't have to go do all this. You can just go right there, my y-intercept is 2. Okay. But let's just go have a look at what happens. We know that wherever there's an x, we're going to go substitute in 0. Okay? If we want this as a coordinate, if our x is equals to 0, do you see we need to go find our y value. That's why we're substituting in so we can go find its friend. Okay, does that make sense? Okay. So if I put 0 into my equation, I put this whole thing into my calculator, I'll get that y is equals to 2. Do you see, from my equation it's given. So we don't even need to go do any calculations. Okay, so again, proper notation, what we're going to do is we're going to go write it down as a coordinate. And our coordinate is going to be 0 and 2. Are you all okay? Makes sense? Right, now that we've got both x and y intercepts, we can go and plot them on our Cartesian plane. Okay? And we can join our dots. Do you see how they've drawn it? Are you guys okay? Do you know how to sketch?
Yes.
Okay? So we've got negative 6. So on my x, okay, because the negative 6 represents your x, you're going to jump negative 6 units, or you're going to jump 6 units to the left. And you're going to draw your dot because our y is 0. We don't move up and we don't move down, we stay right there. Okay? Yes?
Also, ma'am, are your coordinates always going to be either on your y-axis or your x-axis?
If we're calculating an intercept, yes.
So, ma'am, when is it when our coordinates...
Okay, right. So, our next coordinate is 0 and 2. So, 0 represents x. Do I move left or right? No, I stay at the origin. 2 is my y, so I move 2 units up. Okay. Do you see I've labeled my intercepts?
Yes,
And I've labeled my graph. Can you see? What equation? What was the name of this equation? F of x. So you need to go and label your graph f. Okay, do you understand? Move on. Okay, we've got example 2 here. So we just did example 1. Okay, example 1 was a nice easy sketch. Okay, example 2. G of x is equals to y. Again, same thing. Okay. Gx equals y equals negative 2x. Okay, this is a special case. I actually want you guys to put an NB over here. Okay, there's a reason why we gave you this one. Okay, so like I said, if they ask you to sketch, first thing you're going to do is you're going to have a look at the equation they gave you. Are you with me? Okay, and what equation is this? We can see it's a linear. Okay, the reason why is because our exponent for x is 1. When we move on to quadratic, it becomes 2. When we move on to exponential, it becomes an exponent and we'll